Trigonometry, Part 1, Chapter R. Trigonometry can be classified into three kinds. They are 1. Analytic, 2. Plane, and 3. Spherical. We'll discuss analytic. This deals with angles in the Cartesian coordinate system, that is, on the graph. Angles here can be of any size, both positive and negative, such as 3,850 degrees or minus 250 degrees. Positive or negative. Next is plane trigonometry. This deals with triangles in the plane where the sum of the interior angles equals 180 degrees. And finally, spherical. This deals with triangles whose sides are the great circle, and the sum of the interior angles in such a triangle is larger than 180 degrees. Spherical trigonometry is involved in navigation. Trig for short. First, I want to explain what an angle in standard position means. We require axis of the Cartesian coordinate system. This is the x-axis, this is the origin, and this is the y-axis. First, we must draw one arm of the angle along the positive x-axis, emanating from the origin. This is referred to as the initial arm. I will draw an arrowhead at the end of it to indicate that this is a half ray. We imagine another arm, the other arm of the angle, attached at the center again, rotating in the counterclockwise direction, and let's assume that it stops after rotating 145 degrees. This is referred to as a rotation angle, or simply angle. The direction of rotation, which is counterclockwise, is considered positive rotation. I'll put an arrowhead at the end of this line. It is referred to as the terminal arm. Positive 145 degrees. We can consider the angle that the two arms make in this other direction, beginning with the initial arm, rotating around, and finally stopping at the terminal arm. And I will indicate that angle by using a curved arrow. That is negative rotation. Notice that we have two angles, this one in red and this one in green. Since the total number of degrees in a complete circle is equal to 360 degrees, and this is a negative angle, the amount it must be is 360 subtract 145, and that makes it negative 215 degrees. Angles having the same terminal arm, which these two angles do, are called coterminal angles. Both of these angles are in standard position. If I assume the terminal arm producing a rotation angle where the rotation makes several complete revolutions and then finally stopping at the position where the terminal arm now is, we will have another coterminal angle. For example, if I rotate completely around once and completely around twice and stop at the terminal arm after two complete revolutions, that angle is equal to twice 360 degrees plus the 145 degrees, and that amounts to 865 degrees. We could have rotated the arm in the negative direction several revolutions if we wanted to produce a much larger negative angle, which would also be a coterminal angle. In fact, coterminal angles are integer multiples of 360 degrees of any given angle. For a given terminal arm, there are an infinite number of coterminal angles. Further significance will be given later regarding coterminal angles. There are three different units of measurements in use to measure the size of angles. And they are 1 degrees, which I have already mentioned, 2 radians, and 3 gradient. I will be emphasizing the first 2 only. Degrees. Here are some conversion facts. One revolution, of course, is 360 degrees. The symbol for degrees is 1 degree is equal to 60 minutes. And the symbol for minutes is a single quotation mark. And finally, 1 minute is equal to 60 seconds, the smallest unit used. Convert 42 degrees, 32 minutes, and 45 seconds to a decimal degree. Begin by changing 45 seconds to a fraction of a minute as a decimal. In other words, 45 seconds is equal to 45 over 60 minutes, which by using a calculator, 45 divided by 60 or 3/4 is equal to decimal 75 minutes. So now what we have is, so far, 42 degrees, 32.75 minutes. The result so far is 42 degrees, 32.75 minutes. Continuing then, we have that 32.75 minutes is equal to 32.75 over 60 degrees. This amount is in degrees. Calculating 0.5458 repeated. We'll stop there. Hence, 42 degrees, 32 minutes, and 45 seconds is finally equal to the amount that we want as a decimal is equal to 42.5458 degrees. Most calculators require that the size of an angle given in degrees, minutes, and seconds be converted to a decimal degree before you can make calculations. Another example is to change a decimal degree into degrees, minutes, and seconds. I'll use 146.6754 degrees, and it must be changed to degrees, minutes, and seconds. Looking at the decimal portion of the degree, since there are 60 minutes in 1 degree, then this fraction of that amount will give you the number of minutes. So 0.6754 multiplied by 60 minutes using your calculator amounts to 40.524 minutes. So now we have the answer so far is 146 degrees 40 minutes. This is a portion of a minute, and a minute is equal to 60 seconds, so we're going to change the decimal portion of that minute into seconds. So continuing, if we take 0.524 and multiply it by 60 seconds this time, we'll get the fraction of 60 seconds that we want, is equal to 31.44 seconds exactly. The result in degrees, minutes, and seconds is then 146 degrees, 40 minutes, and 31.44 seconds. The second type of measurement I'll deal with is the radian. The radian of an angle is the angle at the center of a circle which subtends an arc equal in length to the radius. Let's take this to represent our circle with this as its center. Draw a radius. Take the length of the radius and, as in using a string, wrap it around the circle until you have a length equal to the length of the radius. Let's say approximately there. Theoretically, these are of equal length. Then the angle at the center is 1 radian. That is 1 radian measure. To make some association with a geometric figure which you are already familiar with, let me assume that this arc is straightened out so that I have then a complete triangle, resulting in a triangle. What we have here then is what you've probably already guessed is an equally angular triangle. That makes this 60 degrees, 60 degrees, and 60 degrees. Since this is a stretched out length compared to the arc, it follows that 1 radian is slightly less than 60 degrees. In fact, 1 radian is approximately equal to 57.3 degrees. So in 360 degrees, or 1 revolution, by dividing 360 by 57.3, this amounts to approximately 6.28 radians. If you divide 6.28 radians by 2, the number is 3.14. Do those sequence of digits remind you of anything? Want to do the work now that will convert an angle from radian measure to degree measure and back. The number of radians in one complete revolution of the terminal arm will now be determined. The larger the angle at the center of a given circle, the larger will the length along the circumference be. And this relationship is directly proportional. For example, then, translating this English statement into mathematical symbols, we can say that C is equal to K times theta, where C is the circumference, theta is the measure of the angle, at the center, and K is the constant of proportionality or of variation. Solve for K. K is equal to C over theta. Now, when theta is 360 degrees, C is equal to 2 pi r. The formula for the circumference of one circle. Therefore, substituting to solve for K, K is equal to 2 pi r divided by 360 degrees. Then C is equal to 2 pi r over 360 degrees times theta. Now, notice that when you have 1 radian at the center of the circle, that the length of the arc along the circumference between the arms of this angle is also equal to 1 radian. So then, when C is equal to 1 radian r, or the radius, then theta is equal to 1 radian. And I will use small r to indicate a radian measure. Substituting C and theta for the final conditions, we end up writing that r, for the length of the radius, is equal to 2 pi r over 360 times theta, which is 1 radian. Simplifying this work, we find that 360 times r is equal to 2 pi r times 1, which is 2 pi r radians. Simplifying, we find that pi is equal to 180 degrees. This represents the conversion statement from degrees to radians or from radians to degrees. For example, convert 240 degrees to radians. Since 180 degrees is equal to pi radians. Since 180 degrees is equal to pi radians, then 1 degree is equal to pi divided by 180 degrees. If 1 degree is equal to that many radians, then 240 degrees will be 240 of those. Therefore, 240 degrees is equal to 240 multiplied by pi over 180, and that is equal to 4 over 3 pi, or 4/3 pi. If we leave pi as the symbol in the answer, then you have an exact solution. If you now convert this to a decimal, which at times you will likely have to, you should then take 4 1/3 and multiply it, I should say 4/3, and multiply it by 3.14159 as the value for pi, written as a decimal. Working this out using your calculator, we have 4.1888 approximately. Here are some more examples. Convert 36 degrees, 42 minutes, and 30 seconds to radians.